Hello everyone, welcome back to the channel. Today we're going to be discussing a very cool observation problem, and you would have seen it in the video title also. The problem is subarray with zero sum. So why am I calling it a very cool observation problem? You'll find out why in the next section. And I have put timestamps on the video player so that you guys can jump around. But for a better understanding, I'd recommend you guys to watch the video from start to end. And now let's get started. So let's discuss the problem statement and understand what the problem wants from us. So problem is very simple. It's just, we are just given an array of integers, right? And we have to check if, the array contains a subarray with zero sum. Now, what is a subarray? Subarray is the segment of array made of contiguous array elements, right? So a subarray in this would be 3, 4, 5 would be a subarray, but 3, 4 minus 9 would not be a subarray, right? So this would be a subarray, but 3, 4 minus 9 would be a subsequence and not a subarray, right? So with that in mind, with that clear, I think we can move ahead and talk about the problem now. So if you see in this array that I have here, we have 3, 4, 5, and minus 9. So in this array, if you see 4 plus 3, 7, 5 plus 4, 9, and this 5 plus 4, 9 minus 9. This is a zero sum subarray, right? So we return true. Like, so suppose we have a function which takes an array and returns whether that array contains a zero sum subarray or not, right? So we just return true in this case. So we return true, right? Now, suppose if you have another array, let's say the name of the array is A, and it contains 1, 2, 3, 4, 5, right? In this case, do we see is there any array with sum 0? I think all are positive numbers. There's no way we can get a sum 0, right? So we return false, right? Similarly, the entire array itself can be a zero sum subarray, right? So let's say an array B is 1, 2, 3, minus 6, something like this. 3 plus 2, 5 plus 1, 6 minus 6. So this entire array becomes a zero sum subarray and we return true in this case. So this is what the problem is. Now let's understand the basic algorithm for solving this problem, and then we'll jump on to the cool observation of this problem. Alright, so now let's discuss a simple approach to solving this problem. So the simple and the most naive approach to solve this problem is to simply consider all the subarray. And how do you consider all the subarrays? We basically have two loops. The outer loop basically goes from this, suppose we are starting at this zeroth index, 0, 1, 2, 3, right? Then we consider all the further numbers left. So right, with 3, we'll consider all the sums, right? So 3 plus 2, 5, right? So we'll do 3 plus 2. Is this zero sum subarray yet? No. So we let go ahead. But the outer loop is at 0 only. The inner loop will go to each element ahead of that number, right? Then 3 plus 2 is 5, not 0. Then we go to 3 plus 2 and then we see minus 5. So 5 minus 5, 0. Then we say we have found a subarray, right? So, but this is a very nice case in which you found it very early. There could be a case in which the worst case complexity would go that you have to go to the end of the array and you are still not able to find any zero sum subarray. For example, right? So 3 comma 2 comma 1. Let's take this, right? So let's say B is this. So you'll start at 0 and 2. You start at 0. You check from 0. You check 0 itself. It's not the 0th index element. It's not 0. Then from 0 to 1. Then you check from 0 to 2. Then you check from 1 to 2. Then you check the element 2 itself. So 1, 2, 3, and so on. The iterations increase as along the number of elements in the array increase, and this grows on exponentially. So this is a naive approach, obviously a doable approach, but a naive approach. And that's what not we are here for, right? We are here for what is the cool observation required in this problem to solve this problem beautifully in just linear time. Let's check that out now. So before jumping into the cool observation part, if you guys are enjoying the video, make sure you press that thumbs up button. If you aren't subscribed to my channel, make sure you press that red subscribe button now. And now let's continue discussing that great observation trick. So the cool observation tricks begin with the assumption. Not an assumption, I'll show you what the observation is. So, I mean, you know what? Let's just dive right into it and let's see. So, what I'm going to do is I'm going to maintain a list of sum that I've already seen, list of sums that I've already seen, right? So I'm going to say sums is equal to an empty list for me, right? I'm going to put every time I see sum. So I've seen 1 till now, right? So I'll put sums is equal to 1 now, right? Then I go ahead and I see 2. Sums is equal to 3 now. 1 plus 2 is 3, right? Then I go ahead. Oops, sorry, 1 comma 3. Both of them are we're going to store, right? And then go ahead, we have 3 plus 3 is 6. So we have stored 1 comma 3 comma 6 till now, right? And then sums is equal to 6 till now, and now 4. We get 10. So 1 comma 3 comma 6 comma 10. Is there any sum value which I've already seen till now? No, right? No. Now let's go to next number, and 10 minus 4 is 6. So we get 1 comma 3 comma 6 comma 10 comma 6. Then after that, a crucial check though here though. We've already found a value of sum which we have already seen, right? And we say that we found a zero sum subarray. Can you take a moment and see why this observation works here, why this conclusion works? You can pause the video and think about it. And for those of you who want to continue, let's just see. So the cool thing is that every time a sum value repeats, anytime a sum value repeats, it means that in between that there was something that did made the sum not increase but made the sum exactly the value which I've seen earlier. So this means the difference between this value and the sum at this point is 0, which means that the value of this subarray, which is in between these 2 points, is definitely 0. Sum of the subarray present between these 2 points, right? Because the difference is 0. And that's how we conclude that the subarray with zero sum can be checked by maintaining a list of all the sums we have seen already before. Now, one case when the entire subarray has zero sum is to, kind of basically check if the given sum becomes zero also at a point. We can have two kind of check, or otherwise we can assume that in the list we have zero also, right? So that's just a corner case for this problem. Now let's write code for this problem and see it come through. All right, so let's dive into implementation right now. So I'm gonna say I have a variable called sums already seen, which is a set. I mean, it's efficient to use a set instead of a list, right? Because of how hashing is better than always looping over the list to find if you have already seen the list, or if you have already seen the sum before or not, right? And then we can have basically an array, which I think I'll just take here as a list, 1 comma 2 comma 3 comma 4 comma, let's say minus 4, and then 5, right? Something like this. We know the answer is yes. So I'm gonna say, let's see, for I in a array, right? And then I'm gonna already add sums already seen dot add 0. I'm gonna add 0 already into this array so that um, the case of having an element as 0 or having the case of entire array sum being 0 is covered. So if sums already, so right, we'll have right. So let's define a variable called sum. I'll rather call it as array underscore sum plus 0 for I in array underscore sum plus I, array equal to array underscore sum plus the current number that we have, right? So if sums already seen dot contains array underscore sum, or no, right? This is Java way, right? So I should rather say if array underscore sum in this, then you just print found a sub array with zero sum, and we basically do sys dot exit, or what would be a better way? Yeah, let's just continue with this and let's see. Otherwise, we put it into the sums already seen dot add array sum, right? So if you already found it, we can do sys dot exit 0. Yeah, this looks fine. We'll also have to do import sys, right? And then I think we can just do print sub array with zero sum not found. Let's check it out if our code works or not. We should get an answer as yes, right? So I'll just get item. 1 second. Item. Yeah. Python3 code.py. Found a subarray with zero sum, right? And if we jump to our VS Code again, and we see, let's change it to some array with, maybe change it to 6. So we should get subarray with zero sum not found. Let's check it out. So we have Python3 code.py subarray with zero sum not found. Let's check another test case. Right, so I'm going to make item disappear, go to code, and then I'm going to say, let's see, 1, 2, 3, 4, 5, and it's 9, 12 plus 3, 15, right? So I'm going to write minus 15. Let's see. I'm going to bring item up, just found a subarray with zero sum. So this works for all the test cases. I'm sure you would have enjoyed working with this observation, that cool observation part. Well, that was it for this cool problem. I hope you guys enjoyed it. And if you did, make sure you press that thumbs up button. And also, if you haven't subscribed already, make sure you press that subscribe button as well. And now I'll see you guys in the next video. Until then, take care. Bye bye. Have fun. Hang out in the comment section with me.